Okay, I took a look at these two problems that I had difficulty with.
Mm-hmm.
Let's look at the easier one, 54. If f of x is equal to x cubed minus 3x squared plus 2x plus 1,
Mm-hmm.
and a reflection across the y-axis means this. In other words, I am going to substitute minus x for x. So what is f of minus x equal? This is reflected across y-axis. In other words, whenever I put a minus x in place of an x, I'm reflecting it across the y-axis.
So is it negative x cubed minus 3x squared minus 2x plus 1?
Very good. In other words, you only substitute minus x wherever you see x.
Okay.
So this would be the equation reflected over the y-axis. Let's go back and look at the other one. I was taking the wrong approach on this before. I tried factoring it, and then graphing it, and then graphically shrinking it by 1/4 was the approach I took. Let's take a different approach. If I represent this as x minus 2 quantity squared minus 1, notice that that's the same thing.
Uh-huh.
Well, why did I choose to represent it like this? It's because notice that this is a function that has been moved to the right 2 units and down by 1. In other words, that function that I graphed, where it went through points like that, that is this. It's a parabola that's moved to the right by 2 units and down by 1. Right?
Okay.
Okay. So if this is what we're looking at and we want to do a horizontal shrink by a factor of 4, then I need to look at f of 4x. Well, I don't really want to look at f of 4x. I want to look at f of 4 times x. And that would give me 4 times x minus 2 quantity squared minus 1. Now, if I multiply this out, I get 4x squared minus 16x plus 16 minus 1 plus 15. Wasn't that the answer?
Let me check. Yeah, I think it was. No, it's 4x squared minus 16x plus 12. Oh, because the 1, wouldn't it be a 4?
Yes. Yes, it's 4 times that whole thing. So it would be 16 minus 4, so it would be 12. Okay. Good. So that's just an easier way of applying that factor. based on the techniques we used for all the other problems. All right. We finished the rest of this page. So
Yeah.
let's open up this new one. One leg of a right triangle is 3 times as long as the other. Write the hypotenuse as a function of the length of the shorter leg. What should I call the shorter leg?
S.
Okay. What's the longer leg?
L.
What's the first sentence? One leg is 3 times as long as the other.
So would it be 3L?
3S. Did you say L or S when I said?
Oh, L, but...
Oh,
no, S is fine. S is fine.
It can be any variable. It could be X as far as that goes.
Right.
So now tell me what the hypotenuse is. Using the Pythagorean theorem.
What's the hypotenuse again?
That's the side that's opposite the right angle.
Okay.
And the hypotenuse squared is equal to the sum of the square of the sides. There's the Pythagorean theorem right there.
Okay.
So in this case, h squared would equal s squared plus 3s quantity squared. So let's simplify this. What's h equal to?
Is it 4S? Or, wait.
Well, we got to square these, and then we got to take the square root of everything. So when I solve for h, I got to take the square root of the right side.
Right.
Okay. What's h equal to? What's s squared plus the quantity 3s squared equal to?
Is it 4S?
Square 3s.
9.
9s squared.
S squared, yeah.
So now you have s squared plus 9s squared.
So then, would it be...
What's s squared plus 9s squared?
10S to the 4th?
10s squared. When you add apples, you get apples. If I was multiplying s squared times s squared, I would have s to the 4th. But when I'm adding variables with exponents, if I got 1s squared and I got 9 more over here, I got 10 of them. In other words, think of s squared as an apple. If I got 1 apple and 9 apples, I got 10 apples. Okay, now let's simplify this because this isn't my final answer. I can remove something from the radical sign there. What is it? What's the square root of s squared?
S.
Okay, so this is equal to s on the outside, leaves on the inside square root of 10, and that's as good as I can simplify. I cannot reduce square root of 10 any. So my answer is square root of 10s.
Okay.
and that is writing the hypotenuse is a function of the shorter side.
Uh-huh. Okay.
Okay? The circle is inscribed in a square. You can have a square inscribed in a circle, but if a circle is inscribed in a square, this is what it means. Write the area of the square as a function of the radius of the circle. What's the area of the square going to be? What's the general formula for the area of a square?
Is it pi r squared?
That's the area of a circle.
Oh, of a square is just base times height.
So a square is just s squared, which is base times height. It's just that they're both the same. Okay? But they want the area as a function of r. Well, what's the relationship between r and s?
Are they this?
Well, look at it. Do they look the same?
Yeah.
The length of this.
Well,
what's
r
the
is
same as
half
the
of
length of that?
r is half of the side.
Uh-huh. So s equals 2r. Exactly. Because the other radius going this way, all radiuses are equal, so the side of that square is equal to 2 radiuses. Okay, so let's plug in that for s. So what do I get? Area equals what?
For the circle.
No, for the square. They want the area of the square. Well, we know the area of the square is s squared. They just don't want it as a function of s. They want it as a function of r. So let's take what we got for s and substitute.
Oh, is it r equals s divided by 2?
Well, we want to substitute for s. So we already have s equals 2r. So let's put 2r in there in place of s. Now simplify that. What is 2r squared?
4r squared.
There's the answer.
Okay.
Okay? We didn't need the area of the circle, so we didn't need anything to do with pi r squared. The only thing we needed to know was that the radius was 1/2 of the side length. Exactly. Okay, we have an isosceles triangle. Meaning that side's equal to that side. The base, this is the base, is 1/3 as long as the two equal sides. So if this is b, how long is one side equal to?
B.
If this dimension from there to there is 1/3 of the dimension from there to there, then what is this in terms of b?
3b.
What's this other side?
3b.
So the perimeter is what?
3b, is it squared plus b?
There's no squaring. Perimeter is the sum of the sides. So it's 3b plus 3b plus b. What's that?
7b.
Uh-huh. And there we have the perimeter as a function of b. And that's what they are looking for. Write the perimeter as a function of the length of the base. Well, we let the length of the base equal b.
Okay.
Okay, if Gloria received a 7% raise and is now making that amount, what was her salary before the raise? What's the first step of a word problem? Always? No
Like
matter.
to find the information that you need.
Define the variable and spell out what it is. And usually that's the very last question they ask. What was her salary before the raise? So let's let S equal salary before the raise. In other words, you can almost always let your variable equal to whatever they're asking for. So you start at the back, find your variable, and now let's write an equation that says the first part of this sentence. What do I have to do to her salary before the raise to get it to be equal to $22,470? Her salary before the raise was not equal to that. She got a 7% raise.
Do you times x by 0.07?
Well, that would be the amount of the raise, but she got her original salary also. So it would be 1.07. In other words, if I multiplied it by 0.07, I would just get the size of the raise. Well, the size of the raise is only going to be $1,500 or so. But if I take her entire salary and multiply it by 1.07, then I'm giving her her salary plus the 7% raise. You see that? In other words, if I gave her her salary, I would give her S plus 0.07S. That is equal to the amount. Okay. Well, these two things add to 1.07S. In other words, this is 1S plus 0.07S. So the only thing I have to solve is that equation. On your calculator, solve that equation for S.
Okay. $21,000.
Right. Okay. Now let's see if that makes sense. Okay, you were making $21,000 and you got a 7% raise. So multiply 21,000 by 0.07. What do you get?
1,470.
So I'm going to add that to my original salary. And I get 22,470, the amount that we're supposed to get. So we did it right. But notice that instead of multiplying 21,000 by 0.07, I would have been just as well to multiply it by 1.07, and then I would have gotten that figure immediately.
Okay, that makes sense.
What's the first step on 63? Remember the
we have to
first,
find the variable.
define your variables and spell out what they mean. So give me, doesn't matter what you want to call them, but tell me what they mean. When it says find the dimensions of the swimming pool, they want the length and the width.
Okay,
So L equals length, W equals width. Now we can write some equations. What does it mean if it says the perimeter is 58 meters?
That the length times the width equals 58.
That would be the area.
Length plus the width.
2 lengths plus 2 widths.
Yeah, I know.
Okay, because this is W over here also, and this is also L. So the perimeter, which is 58, equals 2L plus 2W. Well, that's not going to let me solve for L and W because it's only one equation and 2 variables. But they give us another equation. What's the second sentence say?
The length is 5 meters more than the width.
Give me an equation that says that exact thing.
Is it L plus 5 equals W?
No, is means equal. So L equals 5 meters more than width. What's that going to be?
W plus 5.
Exactly. So now we have 2 equations, the same 2 unknowns, and we can now solve it. So solve these 2 equations for me.
Okay.
And tell me how you're going to solve it. What are your 2 primary methods? What are the 2 methods for solving 2 equations, simultaneous equations?
Substitution and elimination.
What are we going to use here?
Maybe substitution.
Yeah, because one of the variables is completely defined. Okay, so tell me what next to write.
Well, 5L equals W. Or we subtract 5.
Where are you getting 5? Okay, if we're going to substitute, then wherever we find L, we're going to substitute W plus 5.
Okay, so it's going to be 2W plus 5.
Start with the left side of the equation.
58 equals 2W plus 5.
It's 2 times the quantity W plus 5.
Yes.
Which is not the same as 2W plus 5. So when you say, you have to include those parentheses, essentially, when you're verbalizing that. Okay, plus what?
Plus 2W.
Now notice we have 1 equation and only 1 unknown. We can solve this. Let's solve it.
So it's 2W plus 10, and then plus 2W equals 58.
Okay.
And then, so it's 4W plus 10 equals 58. And then subtract 10. So 4W equals 48. So W equals 12.
And what does L equal?
W plus, or, oh,
That's right.
8. Yeah, 18.
12 plus 5 is 17.
Oh, 17.
Okay? So that's the dimensions of the pool, 12 by 17. The key in all of these is 2 equations, 2 unknowns.
Mm-hmm.
A square of side x inches is cut out of the corner. Okay, I'm going to draw this one. There's our 8 by 12 piece of cardboard. I'm going to cut out a square out of each corner. And the dimensions on this square is x by x. And then, after I cut out this corner, I'm going to fold this up and make myself a box with no top on it. Okay? So that's the problem. This is a classic calculus problem, actually, but it also works for pre-calculus. Use your graphing calculator to determine the dimensions of the cutout squares that will produce the box of maximum volume. Okay, let's talk about the volume of this box.
Mm-hmm.
What is the volume of a box equal to?
Is it base times height times width?
Yes, it's the 3 dimensions. In other words, here's our open box.
Mm-hmm.
It's hard for me to draw. Doesn't look like an open box, so I'll erase it. But if I have a box, think of a rectangular brick. The dimensions of a rectangular brick are its width, length, and height. If you multiply all 3 of them together, you get its volume. Same thing with a box. If I wanted the number of gallons that would fit in that swimming pool from the previous problem, I would take its width times its length times its depth. And that would give me the volume of the swimming pool, and then I could figure out how many gallons I could put in it.
Mm-hmm.
Well, width times length times, let's call it height. What is the width of my box? What is the dimension
12.
from here? Now remember my box. Remember what my box is. This is going to be the base of my box, the dotted line. Because after I cut out the corners and fold up those sides, this is the bottom of my box. So what's the base of it?
12 minus 2x.
Very good. What's the length of it?
8 minus 2x.
And what is the height of it?
I don't know, x.
In other words, this height from here to here is going to be the height of the box, right? Because I'm going to fold this flap up. This flap over here is the same height, x. This flap here is the same height, x. So the height is just x. So now we have the volume equals, well, let's multiply these 3 things together. Let me see if I can do it quickly in my head here.
It's 96.
96 minus 16 and 24 minus 40x plus 4x squared. That's those two things multiplied together. And then I'm going to multiply the whole thing by x. So if I list it in order of size, I've got 4x cubed minus 40x squared plus 96x. That's the volume of my box.
Okay.
Now let me show you what they mean. By graphing it and figuring out the maximum. 4x cubed minus 40x squared. 4x cubed minus 40x squared. What's the last number?
Plus 96.
X. Okay, there's my function. If I look at my original problem, what's the maximum x can be? From that picture.
One.
Well, I could theoretically make it 4, but then I would be cutting out this entire half and this entire thing, and I wouldn't have a box anymore. I would just have two pieces of paper that folded up and touched one another. But even still, I can say that there's no way x can be more than 4, right? X has to be less than 4 because I got to have two of them fit in 8. In other words, there's no way x could be 5 because you wouldn't be able to take 5 out of that and 5 out of this. It's only 8 inches long. Okay? So I know I'm only looking for a maximum of the volume. In other words, if I look at this picture, where's my maximum occur? Well, over here, right? But notice that x is greater than 6 over there. We know x has to be less than 4, so what I really want is where does the maximum occur between 0 and 4? Because I know x has to be less than 4.
Like 50?
Like right there. Now on your calculator you can figure out what that x value is. You know how to do that?
Yeah.
Okay. As long as you know how to do it and you're comfortable with doing it, you don't need to do it now. But it looks like the x value is about 1.8 or something. Remember, the question was they want the x value. Use the...
So you would find that.
Determine the dimensions of the cutout squares that will produce a box of maximum volume. Notice that if these squares are only 1/10 of a millimeter, I'm not going to have a very high box, right? So volume's not going to be very big. On the other hand, if I made these x's 4 inches, I've got no width. So I got a 0 width, so the volume of my box is going to be 0. So there is some value of x that makes this box bigger than other values of x. And the way we find that out is by graphing the function and then finding out what that value of x is right there. So did you do it on your calculator?
Yeah, the window's kind of weird.
Yeah, you have to put a trace and mark a spot to the, you have to choose maximum from your functions. and then
Yeah.
make it trace, click to the left of that peak and to the right of that peak, and it'll tell you what value of x is that peak.
One second.
Okay? It's probably worth waiting and having you do this just to make sure you can do it.
It's my window that.
Well, all you need is this part of the graph in the window, right there. You can get that part of the graph in the window, then you can find the maximum. You don't care if the rest of it's in there. We're not trying to find a maximum of the whole function. We're just trying to find a maximum about this point right here. If you want to set up your window, you can make your x's go from -5 to +5 in increments of 1, and make your y's go from -100 to +100 in increments of 10. And that'll give you a nice viewing window.
Yeah.
Now find the maximum in that viewing window.
Is it like 1.4?
Could be, I guess. Yeah, that's 1 right there. So yeah, 1.4 sounds about right.
Okay.
Does it give you a y value also?
Yeah, 58.
Okay, that looks right. That looks right also. But they don't ask for the volume of the box. They ask for the dimensions of the square you're going to cut out. So the square is going to be 1.4 by 1.4. In other words, if I really had such a piece of cardboard and I cut out a square 1.4 by 1.4 out of all four corners, folded it up into a box, I would have the biggest box I could possibly form.
Okay.
Okay? All right. Let's go to the next one. Sue invested $10,000, part at 4.1, part at 6.6. How much is invested at each rate if a one-year interest payment total is $568.75? First step?
Find the variables and define them.
Okay, give me variables and define them.
Should we use X could be in how much is invested?
X and Y. X is the amount invested at what percent? In other words, she invested two different amounts of money. She invested $10,000 total. She invested some of it at 4.1%, but the rest of it at 6.6%. So I could use two variables, invested at 6.6%. This is really the easiest way to understand it. I'm going to do it with two variables, and then I'm going to go back and show you how to do it with one variable only.
Okay.
The best way to understand it is to use two variables. The key is knowing that she invested two pieces of this $10,000 One of them at this annual interest rate and the other at this annual interest rate. The total interest she earned after 1 year was this amount. So I need two equations. What's one of them? What's x plus y equal?
X plus y equals, is it 568?
No, that's the interest earned. Remember, x is the amount of the 10,000 that was invested at that interest rate. Y is the rest of the 10,000 that was invested at this interest rate. So what does x plus y equal?
10,000.
Okay, there's one equation. We can't solve it from that. But we know that the second equation, if she earned a total of this amount of interest, well, how much interest did she earn on the x portion? Let's say she put $4,000 in here. How much interest would she have earned? X times what?
Oh, 6,000?
If I invest at a 4.1% annual interest rate, then I'm going to make 0.041 times whatever amount I invest. So this would be the amount of interest I would earn from the amount that I put in that part of the 10,000. Well, I'm going to earn a little bit more interest rate on the rest of it, the y part. What do I earn on the y part?
0.066.
And together, in other words, this is the amount of interest I earn on the x portion. This is the amount of interest I earn on the y portion. Together, they have to add to 568.75.
Okay.
There's your second equation. Now, all of these problems are going to give you, well, two equations and two unknowns. We can spend the time solving it once we get to this point, but if you know how to do that, let's not waste our time doing it. But I want to make sure I want to make sure you know how to do it.
Yeah, can we just do it?
Okay. Normally, this might look like a situation where you could use elimination, because I have the x and the y on the left side, I have a number on the right side, and in the second equation I have the x and the y on the left side and a number on the right side. But because of these coefficients, it's not the easiest thing in the world to do. So let's solve it by substitution.
Okay.
If x plus y is equal to 10,000, what is x equal to?
Is it? Oh, it's just 10,000, right?
X plus y equals 10,000. What is x equal to? Manipulate this equation so that you end up with just x all alone.
Yeah, so 10,000.
Minus y.
Oh.
You see why?
Yeah.
I have to subtract y from both sides.
Mm-hmm.
So this equation is the same as x equals 10,000 minus y. So now I'm going to use substitution to solve this. So wherever I see x, I'm going to substitute 10,000 minus y. So now let's rewrite this second equation using the substituted values. So tell me what to write.
So like in parentheses, 10,000 minus y times 0.041 plus y times 0.066 equals 568.
Okay, now we got it down to one equation and one variable. You know how to solve this?
Yeah.
Okay, so once we get a solution for y, let's say y comes out to be $3,000. How much, what's x? What's x?
7,000.
$7,000, because x and y had to add to 10,000. So the answer is she invested 7,000 at that percentage, and she invested 3,000 at this percentage. Now,
Okay.
that's not the correct answers because we didn't actually solve this because I didn't want to take the time to solve it. But once you solve for y, x is easily solved for by subtracting whatever y is from 10,000. Okay? Let's go back and look at this problem one more time. Only this time, I'm going to take a shortcut, and I'm not going to call the second variable y. I'm going to call it 10,000 minus x. In other words, I'm going to incorporate the information that I know, which is that together they add to 10,000. So if x is the one amount, the other amount must be 10,000 minus x. So now when I go to write my equation, I can write it straight out. 10,000 minus x times 6.6 plus 0.041 times x equals this. One equation, one unknown, you're done. So it's slightly easier to work in one variable only, except this leap is not that easy for everybody.
Right.
Coming up with 10,000 minus x as your second variable is tough. So I actually prefer to work this as a two-variable problem because you can understand it more. You understand the concept a little better if it's a two-variable problem. But notice that if I used y and the first equation was y plus x equals 10,000, well, that means x equals 10,000 minus, or y equals 10,000 minus x. So really, when I use one variable only, I'm actually using two. I'm just making that step invisible.
Right.
Okay, good. Solution problems. Best way to think about solution problems, whether they are an alcoholic solution or a saline solution or a chloride solution, doesn't matter. If I have 10 liters of a 20% alcohol solution, think of that as 2 liters of alcohol and 8 liters of water. You see why? If I took 2 liters of alcohol and 8 liters of water and mixed them together, I would have 10 liters of 20% of that solution would be alcohol.
Okay.
Okay? So these solution problems, it's best to think of the liquid as a solid. In other words, this alcohol is like sand that's going to dissolve in the water. You with me?
Yeah.
All right. So if how many liters of a 20% solution must be mixed with 60 liters of a 70% solution to get a 60% solution? What's my first step?
Define the variables.
Go ahead.
So X can be,
Always look to their question.
yeah, liters
Of
liters
20%.
of alcohol.
20% solution. In other words, since they're asking for that, how many liters of the 20% solution do we have to mix together? Then we're going to let X equal the number of liters of that 20% solution.
Mm-hmm.
Okay. How much alcohol
Hello?
yeah, I'm trying to figure out how to explain this.
Oh, sorry. The microphone's kind of been cutting out, so I didn't know if you were talking.
Oh, that's fine. That's fine. Okay, so on the left, I've got liters of 20% solution. Well, how much alcohol is in the liters of 20% solution? Isn't it that?
Uh-huh.
Because if it's 20 liters, there's going to be 4 liters of it are alcohol. So this expression defines the amount of alcohol I'm going to add to the mix, not the solution, not the 20% solution. That's X. But the amount of alcohol itself is 0.2 times X. Plus, I'm going to add more alcohol because I've got 70% of 60 liters. Well, how much is that? That's 42 liters. So there's 42 liters that I'm going to mix it with. And to get a 60% solution, well, that would be 60 times the total volume, which is going to be 60 liters plus X. Remember the amount of liters that I'm going to add to 60 liters. Now when I get done, I'm going to have 60 plus X liters. For that to be, in other words, this amount here is the amount of alcohol I'm going to have in my final solution. I'm going to have 60 plus X liters, and it's going to be a 60% solution, so I'm going to multiply it by 0.6 to find out the actual alcohol in there. Well,
what about the 70%?
I multiplied that already by 60 to get my 42.
Oh, right.
So I could have written this 60 times 0.7. It would have made a little more sense, I guess. But the key is that is an amount of alcohol, not solution. That is an amount of alcohol. When I add them together, I should have the same amount of alcohol. Well, the final amount of alcohol I'm going to have is going to be 0.6 times the 60 liters plus the X liters that I added. So, here's my equation. There's only one variable in it. I don't need that. That's a unit. In other words, I got 0.2x plus 42 equals, if I distribute this, I got 36 plus 0.6x. Now that's easily solved. I get 0.4x equals 6, x equals 15. So I have to add 15 liters of a 20% solution to 60 liters of a 70% solution. When I mix them all together, I will have 75 liters, and it will have a 60% solution. But the key to these solution problems, once again, is to figure out how much alcohol is in there.
Okay.
Or if it was a salt. I could replace the word alcohol by salt. A 20% salt solution would mean 20% of it would be pure salt. 80% would be water. So think, even though alcohol is a liquid, not a solid, it actually helps to think of it as a solid.
Okay.
Okay? All right. Well, we didn't quite get done. We got through 66. How many more do we have on here? Just a few. All right, well, another session's worth. Based on the difficulty of these problems, we're not going to get a whole lot of them covered in 1 hour.
Yeah, that's fine.
Okay?
And I just had a really quick question. How do you find the YouTube videos again that you like record?
Let me find yours. I will send a link to you right now through GoToMeeting. We tried this once before, and that link doesn't work, does it? You don't see it when I put it in there. Okay, it's ID 35 HTML. So hold on. If I go to my website, click on any link other than home, and it gives you this ID. Well, you want to make sure that says ID.35.
Okay.
Goes to your page, Morgan, right there. Okay? So this was the last session we had. If I play it, it'll just play like a YouTube video.
Okay.
Okay? You can play it like that also. So this is the link that you need to go to. I'm going to try it one more time. I'm pasting it and I'm sending it. Do you see a chat window on your GoToMeeting screen?
Yeah.
Do you see that link? Does your chat window have a plus or a minus sign next to it?
Oh yeah, I got it.
Click on that link.
Okay.
Should go to this page, and then you can save it in your favorites, and you can always get back to it.
Okay. Perfect.
All right?
Thank you.
No problem.